Hello everyone, myself Ganavi, studying at Sri Venkateshwara College of Engineering in the Department of Computer Science. Today's topic is about dairy farming and artificial intelligence. The abstract. The use of near-infrared spectroscopy was explored as a new tool for obtaining information on the molecular level for each individual curve and served as important in vivo applications to underpin the dairy precision farming. Milk, urine, blood serum, and the Raman juice spectral data were measured in 25 cows at different feeding patterns and healthy status. For data minimizing and spectral interpretation, multivariate analysis was performed. In the conclusions, the result indicated that biofluid NIR based assessment was the variable for milk quality classification and biomonitoring for individual dairy cows. This might also aid to feedback control further and help to optimize dairy farm management. Introduction. Dairy farming is a labor-intensive with numerous biological and physical processes that need to be monitored and optimized. The link between the livestock and the crop production includes the opportunity for flexible feedback, differential appropriate feeding of animals, and use of crop residues, manure, and animal traction. Robotics and artificial intelligence offers the potential for dynamic changes in the milking system of future. For this kind of system, economic and regularity benefits is achieved by using the rapid and accurate informations are desirable. In this presentation, the cow's milk was considered as an easy of access output of cow's living system. Milk spectacular monitoring was found to be a valuable tool to reflect substantial changes caused by the input like diet and mammals' health. Interrelations between milk and other biological fluids have been investigated through the NIR spectrum. We also have demonstrated that NIR milk spectra data acquisition at the each milking for each individual cows allowed in vivo analysis of respective physiological conditions. Therefore, NIR spectroscopy has been presented as an individual cow management approach and a powerful technology for dairy precision farming done on a molecular level. Materials and method sections. Dataset the dataset 1, the 7 Holstein cows in early location. The investigation showed wavelength ranges from 400 to 1100 nanometer. The NIRS for somatic cells count measurement. 200 milk samples from the evening and the morning milking over 30 to 30 days. In dataset 2, 1045 milk samples from healthy and domestic cows are predicting the SCC during the milking. The samples collected twice a month for 9 months, starting 40 days after paturations. Spectra recorded every 15 seconds during the milking. In dataset 3, 96 unhomogenized individual milk samples. The the feeding trials to improve the feeding management using NIR spectra. In the interrelations milk between milk uh, spectra and the biofluids like blood, serum, urine, and germ juice. Sampling data collections. The first is milk samples collected from the evening and morning milks, healthy and monastic cows, and verifying the temperature during the milking. The second is of sampling group performed to cover the variations in cow individuality, lactation stage, milking time, and the physiological status. Feeding trial in feeding trial 16 lactating Holstein cows and the lactations. High and low milk yield groups are covered. The average body weight may be around of 585 kgs. Dietary like roughage, conciliage, Italian behave, The commercial concrete mixtures and the folk protein supplements like fish meal, corn gluten meal, roasted soya bean, etc. In chemical and NIRS analysis, milk sample analyzed for fat, total protein, true protein, casein, lactose, and milk urea nitrogen. Blood plasma samples analyzed for albumin, glucose, and blood urine nitrogen. Dataset 1 in NIRS system 66500 spectrophometer. The instruments are used is NIRS systems 66500. Measurement mode is transmittance. Wavelength ranges from YSNI region, like from 400 to 1100 nanometer. Sample size like test tube within 12 in diameter. The purpose is to investigate short wavelength range NIRS from somatic cell count measurement. General, the NIR spectroscopy used for rapid and non-deterministic analysis. Different instruments and configurations used for each dataset samples preparation and temperature control crucial for accurate measurements. Reference method Photomastic instruments was used for somatic cell reference measurement. Composite milk samples from individual cows were analyzed for MUN using a commercial analysis kit. All milk samples were analyzed simultaneously with the reference method. For fat, total protein and lactose contents by Wilco scans. Near infrared spectra data treatment. The first is chemometric tools. It is used for calibration, validation, and prediction. It developed the model for NIR measurement. It evaluates the predictive capabilities. Software and programs are MATLAB programming language like MathWork. The custom written programs for input of spectral data, pre-processing, calibration. Calibration and validation statistics are standard error of calibration, coefficient of multiple correlation, standard error of prediction. It is used to evaluate the NIRS determination accuracy. Inter-individual variations and robustness. Calibration repeated with mil spectra from each cow livestock once. The estimated MUN and the log SC concentrations from one cow using milk data from remaining cows. Combined validation results from separate calibrations. Determined inner individual variations and robustness of calibration. Importance of MUN. Indicators of protein feeding efficiency in the dairy cows, the impact to production, fertility and environmental contamination, excess nitrogen contribution to the environment pollution. Challenges with current models, the laboratory-based methods requires the sample acquisition, cannot provide fast information for daily based management, limited to herd level analysis, not for the individual cow levels. Future direction: development of an online NIR method for MUN determination, integration with existing dairy management system, expansion to other milk components and quality parameters, investigation of applications in various dairy farm settings. Effect of feed supplements on milk composition for the development of neutral network model. The effect of feed supplements are different feed supplements caused changes in the milk composition and the yield, changes observed in milk fat and the protein content, and the last, the individual cows responded to the different to the same feeding formula. Neural network model development database created with the type of feed, physiological data for each cows and the milk composition. Model trained using the first feeding trail data. The model updated with the compositional changes from the second feeding trials. Implications are neural network model can predict the optimal protein supplements for each cows. The model can define appropriate feeding formula for individual cows. It combines the spectroscopy with quality milk composition analysis, substantial steps towards the optimizing feeding management. Model performances, best configurations like 10 units in the hidden layer. Training datasets are 95% prediction rate. In conclusion, in this study, it was proved that near-infrared spectroscopy is a powerful technology that has a potential to provide the individual information for each cows on a molecular level. The raw composite milk was found to be a valuable control point where using its NIR spectra various kind of informations were required. This model for measurement of schematics count and the milk, urea, nitrogen in raw milk were developed. This milk spectra and the neural network model proved to be useful for feedback control of each cow's individual diet. It results of near-infrared spectra and the compositional data analysis of biofluids of individual cows showed potential to be further used for in analysis of cow physiological conditions. The result of this work is to represent an important step towards the expanding the boundaries of NIR technology applications to precision dairy farming based on the real-time monitoring and individual cow management. Thank you.